We have a 2012 Infiniti QX56 here, and somebody at one time made a pretty expensive gamble with this thing. It is setting high pressure fuel pump codes, and on the pre-scan here we have a P0090 and a P0088, and then we got some air fuel ratio sensor codes, which I don't know if they are part of what the fuel pressure is doing or not, but I say it's a gamble, an expensive gamble, because they put a high pressure fuel pump on this thing, which is right here, and apparently this thing brand new is $1,500, and it didn't fix their problem. So let's see if we can figure out what's actually wrong with this thing. So we're actually using Autel Ultra, something I just bought. So hopefully the screen recording is working and everything, and you guys can see what's going on it. So first off, I just want to glance at some live data for just a second. I've not cranked this vehicle all day. I cranked it first thing this morning, moved it into the shop because I thought it was actually going to rain today, and it has not. And yeah, it's been sitting for probably about 5 hours now. So let's go into the scan tool here. We're going to look at some live data in this fuel pressure that we've got. So engine speed, we're at 0. Where's the fuel pressure? Fuel pressure, there we go. Not sure if we've got a desired fuel pressure or not. Let's see, we got a duty cycle, injection timing, got a low pressure fuel, low side fuel pressure sensor also. Let's do all these to the top. So right now it's saying we've got 1,800 pounds of PSI, pounds of pressure in the fuel rail. That's pretty high for just sitting here. Like I said, it's not done anything since I moved it in. I would have thought maybe that would have bled off by now, but maybe not. Let's crank it over and just see what kind of fuel pressure we get up to. So 2,800. Our low side pressure 68 psi, so that's all good. That high side pressure, that rail pressure, is a little high. It's a little higher than I would think. I don't actually know what good is on this, but we had those two codes, a P0088 and a P0090. Yeah, and if we go over to the service information, let's see, where have I got it at? Right here. P0090 is fuel pressure regulator A, control circuit open. So this is making me think we've actually got a wire issue going to the fuel pressure regulator on that pump. So we're actually going to do some circuit testing with that first. I'm going to actually be using the scope that's with this, just because I don't have a whole lot of experience with the Autel scope. I've only used one of them one time several months ago, like probably a year or two ago. So I'd like to get used to this scope. It's one of the reasons why I got the Ultra, was for the scope. I'm a fan of having scopes on the scan tools. So that was one of the biggest things I liked about my Snap-on Veris, is the scope being on the scan tool. I use the scope with my top done a whole lot, so now I'll be using this some with the scope. I think the scope's just a powerful tool, and if it's there and handy, you know, use it. So we're going to get to this fuel pressure regulator and scope these wires and see if we've actually got an open circuit or not. Alright, so I'm using 2 channels here, and both of them just grounded straight to the battery. I had to just pierce probe these wires because I couldn't really get in that thing to back probe it at all. So I'm just pierce probed one wire into each one of them, or one channel into each one of them. So let's I got the key off, so let's turn the key on and just see if there's any kind of like circuit test that we can see on the scope. Let's see here. I seen just a little bit of a blip there. Nothing that would really look like a circuit test to me. Let's crank it and see if we have anything happen. Now remember, both sides of this is ECM controlled, the ground side and the high side. So ECM is going to be controlling both sides for some reason. Why can't they make this easy and just do like one side controlled and the other side constant ground or something? Who knows? But let's crank it here, and that looks like a good signal. Let's change our voltage here. That looks fine to me. I don't know how to pause this scope. Let's see. Oh, there it is. It's covered up by my little thing. So let's zoom in here. We can actually see a little bit of a pintle bump. Oh, I don't care about that. We can see just a little bit of a pintle bump there. Like, I don't know how well y'all can see that, but that little bump, that looks like a pintle bump to me. Yeah, having that inductive spike would make me think that we have current flow. If we didn't have current flow, we shouldn't have that inductive spike. That looks fine to me. You might be wondering like what's happening here, and what it's doing is this red trace is the 12 volt turn on. So right here you can see we turned on and we grounded at the same time, and then they pulse with the ground, okay, and then they turned off the 12 volts, and since we turned it off, we get the inductive spike here. Not really sure what the ground is, probably just feedback there. But all this looks normal. This looks fine. And I set this to 50 volts just so I could see this whole waveform here. This clipping voltage is about 30 something volts there. So to me it looks like we've got a good circuit. Where to now? Okay, so now what if there's something wrong with the fuel pressure sensor, the fuel road pressure sensor, and it's skewed and is actually reading incorrectly? Well, here's an easy test for you. Got the live data going so I can see it. I'm gonna actually move it over here where I can see it as this happens. And what I want to do, I just want to take and crack the high pressure line to bleed off the pressure and see what my rail pressure sensor does. There we go, 40 psi. Back up to 100 because fuel's starting to boil in the rail just because of temperature from running it just a minute. But you see, cracked loose, 0 psi. So that's a quick, easy test that proves the fuel pressure sensor itself is actually working correctly. So what could cause us to have high fuel rail pressure and the fuel pump seems to be getting the signal to control the regulator correctly? This thing is a timed pump. There is a cam lobe basically that runs the high pressure pump to actuate the piston in it to build pressure. So what if it's timed wrong or gotten out of time? It's not like your normal high pressure pump that's driven off a camshaft lobe, like an independent camshaft lobe on, you know, like an intake or an exhaust cam. This one's got its own little gear with the cam lobe in the timing chain. So on this timing chain layout, this is the right side bank over here where the fuel pump will go right here. We have right here this little lobe in the little lifter bucket basically. This runs that high pressure fuel pump. So what if this is somehow gotten out of time with this chain? That might be a little harder to figure out. Since there is no position sensor for that, you almost just have to do visual inspection of it. I'm sure if I had an ADDI box, Scott has designed this thing. I think I could probably look at fuel rail pressure along with the command for this fuel pump regulator and probably determine if it's actually in time or not based off of fuel rail pressure and injection timing and then the command for the regulator or the command for the pump. Sadly, I don't have one of those ADDI boxes yet. One of these days I'm gonna buy me one. But let's see if we can figure out some way of testing this without having to take it apart. Alright, so the only thing I can really think of is seeing how the pump reacts with it unplugged. And then I've also got down there some test leads that are just pinned in there that I'm going to connect straight to battery power. All I got to do is just take this one and kind of tap it. And I'm sure maybe you can hear that. So I can hear it clicking. I'm pretty sure it moves, but I just want to watch the live data to see, you know, with it unplugged, does it hit max pressure or is it low pressure? And then is it using the solenoid to build pressure? So let's crank it up, see what happens with our fuel pressure. Okay. And we're at 27. So let's see what happens when I full filled the pump. I can almost hear it. So let's full filled it here. And you heard the pump get quieter. And look at this. We're bypassing all the pressure off of it. So that means the pump can regulate its pressure. Yeah. So I think we're out of time. Well, I have got the cover pulled off. If you're real careful, you can pull this thing off Just be careful about these seals. This thing's got to slide a good ways out to get this out of the intake cam there. But it's bad. It is very bad. So on the bore scope here, you can see this plate is what holds the end of that cam lobe up, basically. And if I snake my camera in here, that cam lobe is worn off extremely bad. So this thing is going to have to come apart and get some timing components replaced in it, and then it should be good to go. So this is as far as I'm going with it. I'm going to stick that cover back on there and give it back to the car lot that brought it to me. Say, tear it apart, put a timing chain set in it, and all new gears and stuff, because that's pretty bad. But I imagine it's out of time. I was hoping I could get in here to where I could see the timing marks, but I don't even know that I can. I mean, you can see a good bit of everything. Let's try to get this stuff out of the way. Got you off the camera stand now, so I'll snake you down in the hole so you can kind of see a little bit. Maybe it'll focus, probably won't. Let's go around this side. There we go. I was hoping I could see the timing marks on the chain and stuff, but the way this intake one is, I don't know that I could actually get in there. And then of course the high pressure pump side, it's got this plate on it, which I could take that plate off and get a better look at it, I'm sure. So let me do that real fast. The carnage in here is a little bad. Not sure how well I can get you in here. Probably not well at all. Let's go back to the bore scope camera. You can kind of see some damage on the side here from something. I'm not really sure what happened there, but let's see. Cam lobe there. It's almost like this thing has like some needle bearings in here that it rides on. It's a little hard to see in that thing, but it looks like that thing rides on some kind of needle bearing type thing. So I'm wondering if maybe something's going on with that in there, because this piece, this is the piece that holds that on there. So you got a bolt going through the middle there, and these two, so it sits on there like that, and this stays pressed up against that to hold it in there. And if you look right there, come on, focus. Not gonna focus. Come on. There we go. About the best I can get you. Got something going on there. Something got in between this. So that's it for this one. Yeah, some damage that's got to just be took apart to fix. So hopefully you guys enjoyed this. Thanks for watching, and we'll see you on the next one. If you've asked before how I take care of the puncture marks, let me find it here where I pierce these. So right there's one, and right there's the other one. I just take and give it a little spray with some brake clean, and then let that kind of clean the wire, clean any oil off of it. These actually have some glue on them from where they convert from these wires over to a shielded cable. But anyways, I just give these a good clean and make sure there's no oil residue on the holes or in the holes. Get them nice and clean and dry, And then I'll just go over them with some liquid tape and let it dry. Let's get this out here. So I just kind of dab some over the areas. Let's see, there they are. Don't need it too thick, but I do try to get it to where it's worked into the hole. There we go. And I'll just let that dry, and then I'll retape this back over it. Most of the time I'll try to individually put round tape over that too, but this isn't really going to be that necessary. I can put this over and tape this whole harness back up too.